Hey, we are in Unit 3, Lesson 4. We're still talking about similar shapes, similar dilations, essentially. So we spent last lesson talking about dilating lines. Let's talk a little bit about angles today. So if I look at these shapes, it says triangle A prime, B prime, C prime, which is your image, is a dilation of triangle ABC, your pre-image, using center P and a scale factor of 2. That means that I could draw a ray if it were going. There we go. That's a beautiful ray. I should do that straight line thing. Oh, there's a ray. That's cool. See, I'm getting better and better at this all the time. Oops. I want another one. Insert. Ray. Okay, very cool. Let's go. Sorry, so many things I'm clicking on. I want to be able to select this and delete it. Let's insert one more ray. All right, so here, scale factor of 2. We've learned how to do that. So what do you think is true about the angles in ABC compared to the angles in A prime, B prime, C prime, and the angles in ABC? What do you think? Right? Use the tools available to figure out if what you thought was true is definitely true for these triangles. So pause for a second. We're going to go over to Geogebra. All right, I just quickly drew triangle ABC. Okay, right there. And I want to try to move that. There we go. And then I drew rays, which we've done in the past. I drew some rays, and then I dilated it to A prime, B prime, C prime by a factor of 2. And we could see really closely, we could see really closely if I measure, let's just do BC, and I measure B prime, C prime, it's times 2. Nothing new there. Okay, we've done that. Now, what's going on with the angles? All right. What I would love to do at this point is to pick this polygon up, this triangle, and like drag it onto here and show you. But, if we had tracing paper, we would actually trace it, pick it up, and show you. But we have a cool thing here. I can actually measure angles. So let's measure angle B. That is 49.3, and then B prime. 49.3. Okay. Pretty cool, huh? Let's do it again. I know, it's more fun the first time. And one of these I'm going to get on the outside. There we go. 89.1. 89.1. I don't know why that's showing me the perimeter. Can we get rid of that? Yes. Angle? One of these is going to be on the outside. Oh, it's not. 41.7. 41.7. So what do we know about angles when you dilate figures? The angles don't change. Do you remember back when we did congruency and we talked about side, 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 angle, congruency theorem, hypotenuse leg? What did we say about angle, angle, angle? You couldn't use angle, angle, angle to prove two shapes were congruent. It didn't work. Side, side angle didn't work either because it spells a bad word. But angle, angle, angle does not prove congruency, but it does prove similarity. Absolutely does. Okay? Pretty cool. All right, let's go back to our work. Oops. Draw, pen. So what do you think is true about the angles? They're congruent. Okay, use the tools available. We did. Do you think it would be true for angles in any dilation? Yes. Yes, it is. Absolutely true. Any dilation, the angles hold. All right, so here's an activity synthesis. ABC prime is a dilation of ABC. So B prime is congruent to B. B is congruent to B prime. All right? All the angles are congruent to their corresponding parts. Okay. All right, so let's do this. Dilate point A using center C and scale factor 3/4. Let's see, let's do a red pen. We're going to do our best. Dilate point A using center C and a scale factor of 3/4. So it's going to get closer. Hold on. So we're going to do approximate. We'll do A prime. Let's see, B, scale factor of 1/3. That's going to be pretty close to C. B prime, point D, scale factor of 3/2. So that means it's bigger. So we're going to go out here. And then dilate line CE using center and a scale factor of 2. Well, I can't dilate a whole line, but I can dilate that point. So scale factor 2 means that's going to double, and we'll eyeball it right about there. Cool. What happens when the center of dilation is on a line, and then you dilate the line? That's what we just did, and it just moved my point out, but lines are infinite, so that really doesn't do anything, okay? What I want to talk about here is we dilated points, but the angles never changed. So if I look at angle ACE and angle A prime CE, or even angle A prime CE prime, they are all congruent. Okay, it didn't change the angle at all. And if I dilate, what happens when the center of dilation is on a line and then you dilate the line, it is the same line because lines are infinite forever. All right, so proof in parallel. Jada dilated triangle ABC using center P and a scale factor of 2. Pretty excited about this. Oops. Maybe I don't have to go into Geogebra now. All right. Jada claims that all segments in ABC are parallel to the corresponding segments in A prime, B prime, C prime. Write Jada's claim as a conjecture. So what we see here is BC, and, well, I can just do this, BC and B prime, C prime. She is conjecturing that these are parallel. Well, let's think about this for a second. What do we know about if I just extend this a little bit? If we think they're parallel, what can we say about, let's change colors, I don't know why, it's pretty small. That angle and that angle. Okay, they are in fact corresponding angles. We have BC is parallel to B prime C prime, and then we could call it PC, or PC prime is the transversal. That was a star. Okay, PC or PC prime is the transversal. Therefore, the corresponding angles are congruent. And I can name that angle, I don't know, let's put an X up here. Angle X, C prime, B prime is congruent to angle XCB. And if I back up, okay, I probably should back up. We absolutely know, we don't know this yet. So this right here, I think I got a little bit ahead of myself. Oops. If I back up and I talk just about the triangles, I can say that A prime, C prime, B prime is congruent to ACB because we just talked about that in the previous task. Okay, A prime, C prime, B prime is congruent to angle ACB. All right, now that's fantastic. And then we can actually lead back and go back to what we talked about here, where I got ahead of myself. If we talk about that transversal and those parallel lines, they are in fact congruent. Let's see, if we do this one right here, let's do a different color highlighter. Let's highlight this one. So we're wondering if these are parallel. And let's talk about this transversal. Okay, congruent, congruent. Now there's way too many things drawn in here. Oh, I erased my rays. Okay, I'm going to show you one more time. If we want to talk about, let's do this one. Oops. We want to show that these are parallel. And the transversal, if we don't want the transversal to be the ray from P through those points, nope. Yeah, we could say this angle is equal to this angle, but they don't have the same transversal. So we're going to stick with this. Okay? Using the ray, the dilation ray, works the best. All right, let's move on and see where we're going here. Right data's claim as a conjecture, so let's do that formally because I've just been chatting. Let's get the wording correct. Move that up a little bit so I have some room to write. So our conjecture is dilation takes parallel lines to parallel lines. Prove your conjecture, okay? I'm doing a two-column proof, which I know they don't usually do. So first, we're going to draw BC. Let's go ahead and draw BC, which we have. And point P not on BC. Got it? Mark point E on ray PC. So let's put that ray in there. Which I had a point X drawn there before, but that's okay. We can do point E. All right, so I'm actually going to erase this. I'm going to take it just a little bit different step to help it make sense. So we're going to draw a ray PC and then draw point E on PC, ray PC. I can say ray PC or I can do PC with a ray over it. That's equal ways to say ray PC. Cool. All right. Next, we are going to dilate segment BC and E a scale factor. Some scale factor, say it's K. Okay, doesn't matter what it is, it really doesn't. So if we did that, we would get C prime, B prime, and I need E to be a little bit closer because I don't have enough space to draw. So we're going to make E, we'll just make E right here. So When I dilate it, it's going to end up right there. So dilate segment B, C, and point E, some scale factor K. And that will give us B prime, C prime, and E prime. Okay, not really a two-column proof because I don't have statements and reasons. We're just doing a lot of construction, and we're going to use the construction to help prove it. So points E prime and C prime will both be on ray PC by the definition of dilation. Got it. So now we have angle ECB. Let's do green. ECB, this angle right here, is congruent to angle E prime, C prime, B prime, because two parallel lines cut by a transversal corresponding angles are congruent. Okay, cool. Congruent, yep. Transversal, corresponding angles. So therefore the lines must be parallel. So actually, I said that wrong. So let me cross off the part I said wrong. So we want two lines, nope. Two lines cut by a transversal, corresponding angles are congruent. Therefore, the lines are parallel. Okay, that I said it in the wrong order, and it's really important to get it in the right order. Okay, cool. Now, in Jada's diagram, and we have that right here. Oh, I should mark that congruent angle. So in Jada's diagram, the scale factor was greater than 1. Would your proof have to change if the scale factor was less than 1? Nope. We good. Okay. All right, and here is just another one. You're dilating through this ray from D to D prime, some scale factor K of greater than 1, and E to E prime, and our lines stay parallel because this angle is congruent to that angle. You know, this angle is congruent to this angle. The corresponding angles are congruent, therefore the lines are parallel. And that's it. Good job today.